Okay, that's April 27th, Monday, Los Angeles Harbor College, and we're going to continue with the topic on AC circuits. That's the syllabus right in here. We are right now on the 27th. We're a little bit late here, so it should be AC circuits number 2. Hopefully we'll be able to start electromagnetic waves today. Don't forget the lab 3 is due today. Let's see, let's take a look at the exam. Exam is the 20th of May, 9:40 a.m. It's going to be, let's see, 1, 2, 1, 2, 3 weeks and a half. 3 weeks and a half from today. That's going to be the partial exam. And let us start with the lecture. Here you go. That's why we want what we want here. And we did last time.
Professor,
Oh, yeah,
we can't see your screen share. Sorry. Someone
share the
said it in
screen.
the chat. Yeah, we can't see your screen.
Yeah, thank you. Thank you for letting me know. Let's see here. Now, share the screen, share the screen. Here you go. Thank you for letting me know. Let's see here. Good. Last time we looked at an AC circuit that has a generator and a capacitor. Today we will look at a circuit, at an AC circuit that has an inductor in the place of the capacitor. Like that. Last time we looked, okay. Let's see, we look at an AC circuit that has a generator and a resistor, right? We did that here. After that, we looked at a circuit that has a generator and a capacitor. Today we look at an AC circuit that has an inductor in the place of the capacitor. Note that the AC circuit with the resistor is the simplest one because both the voltage and the current are the voltage because both the voltage of the generator and the resulting current are in phase with each other, right? So here you go. Let's make a list. Okay, AC circuit. You know what? Let me see if I can come up with a table that's better. It's easier, right? Let's see here. 1, 2, 3. Let's see if we can do that. Circuit. AC circuit. Let's see if the AC circuit, resistor only, capacitor, only, inductor only. Let's see here, the voltage, AC circuit element, AC circuit element, generator, no. Let's see how I'm gonna do that. Voltage, current, amps, like that. The voltage, just a reminder, right? I'm doing that just as a reminder. Yeah. I'm gonna put a subscript of R that on this R for resistor, okay? C for capacitor. And then we have that the current leads the voltage by 90 degrees. And now we are going to see that when you have an inductor, the current is not going to lead. The current is going to lag. Can you remember that? Okay. Let's see. Let's put another one here, reactance, right? That should be omega. Here is going to be just R for resistance. And here is going to be what we saw before, right? And that was what? 1 divided by 2 pi f. Let's see. Go back here. There's the capacitance, C2 pi f. C. And then here we are going to find out, and let's see, reactance. Let's come up with that notation, right? Like that. Here is going to be capacitive reactance, like that. And then we're going to have an inductive reactance here. Let's see what that's going to be, right? And that's what this example is all about. Replace the capacitor as an inductor of inductance L. Use Kirchhoff loop law to find an equation for this new AC circuit with the inductor. write delta I, delta T for the system, and write the current I for the circuit. Here you go. First part right here. Here is the circuit, the generator and the inductor. That's the symbol of the inductor. The coils of the solenoid, right? The coils of the solenoid. We started right in here at this left side of the generator. We move from a lower potential to a higher potential. And we must write VG plus VG. Okay, and then we cross the inductor from this spot to this spot, we put VL. And using Faraday's law, Faraday's law is just another way of writing Faraday's law. The IDT, delta I, delta T times L with the negative sign. Okay, replace it in there. Oh, and let's not forget that VG, VL, VG is V naught sine 2 pi ft. Okay, and now we can substitute that in the equation. This is the equation for conservation of energy in the electric circuit. This one goes here. And we are done with item A. And now I'll write delta I, delta T for the system. All I have to do is to separate delta I, delta T from the remaining equation. I want my delta I, delta T on the left side of the equation. So this guy goes right in here. And the L goes to the bottom. Okay, the L goes to the bottom. That's what my delta I, delta T looks like. And now we can start thinking about the phasor diagrams. Okay, let's add some items here. Show, here, we're gonna show the phasor diagram for VG and delta I, delta T. VG and delta I, delta T, right? We can look at that too. Let's see if I already have that. This is the phasor diagram. Okay, for the currents, right? That's the capacitance. I showed you the phasor diagram for the capacitor, for this AC circuit with a capacitor. Okay, do you see how it looks like? Let's see here. Phasor diagram of the voltage and current in AC circuit, in an AC circuit with a capacitor. Let me change that here. Correct that only. Let's see. Oh yeah, I am rotating it. See that? That's exactly how it looked like in real time. Okay. Capacitor. I put capacitor. I put a resistor here. It's not a resistor. It's capacitor. This is exactly what you're supposed to see in when we animate the whole thing. It is rotating, right? It's rotating as time goes by. Let's go. Let's see if I can do another one. Group. Let's see if I can get that group. Yeah, the only one that I don't want. Let's do that again. The only one I don't want to rotate. Okay, now we can group. Oops, gosh. Why is not clicking here? Okay, now I click it. Oh gosh. Sometimes it clicks, sometimes it doesn't click. Okay, let's see if I can get it now. Group. And now I'm gonna rotate the whole thing so I can get a better animation, right? The V naught continue to be here. And here we go. I didn't put the Q naught there. Huh? It's rotating, right? Here you go. As time goes by, that's what happens to this phasor diagram for the capacitor. And we're going to see something similar for the inductor as well. Okay, V naught, I naught. What I didn't put in there was the delta I, delta T. Let us put the delta I, delta T there. Just like we did for the current, for the charge. Like here, okay. Yeah. I want to send that to the back. Yeah. And I want to put Q there. Q naught there. Wait a minute. No, it's not Q naught. It's going to be delta I, delta T. In this case, it's going to be delta I, delta T because this is the case of the inductor. Oops, what's going on here? Symbol. Delta I, delta T. Okay. If I want to animate that, right? I do exactly what I did before. I'm gonna put the delta I, delta T a little bit closer to the tip. Here you go. Group, rotate. Here you go, rotate. Here you go. Right? We have 3 frames here. 1, 2, and 3. What I told you was that's going to happen to the current, that it is going to lag. The delta I, delta T doesn't lag. The delta I, delta T stays the same. But the current this leg. And like I said before, we cannot prove that here in this course because it requires calculus, advanced calculus, okay? Here you go. The mathematical proof. The mathematical proof for the equation of the current requires advanced calculus. The mathematical proof for the equation of the current requires advanced calculus. So I will just write down